All right, guys, we are going to add to our notebook today, and we're going to shift our focus a little bit. The first half of this chapter is all about graphing. So how do I graph a quadratic in each form? And so now we want to talk about how do I solve a quadratic in each form? So the next page that we're going to add here is Intro to Solving Quadratics. And the thing is, so we're doing that on 112 and 113. We actually first want to talk about how we solve by graphing. So on this page, we're kind of doing two things. We're talking about what it means to solve, what does that look like, and then how do I do it when I'm looking at a graph. So here we go. We turn to 112 and 113. I want to write a little bit on the top of 113. So what does it mean to solve? Because the thing is, a lot of people see the word solve and simplify and they kind of goof them up. They think that they mean the same thing, but they sure don't. Simplify means that I'm not looking at something with an equal sign. I'm just looking at a string of numbers and I'm going to try to smush them down to the least amount of numbers as I can. When I'm solving, I have an equal sign for 1. And for 2, usually I don't know something and I'm trying to figure it out by using reverse order of operations. So generally for us, what it means to solve is that we are trying to solve for x, or like get it alone. And this can come in a lot of different forms for a quadratic. They might ask this in a lot of different ways. So they might ask you to find the x-intercepts. And that really just means solve for x. They might ask you to find the zeros or the roots. But all of these things just mean what is the solution? Find the solution. They all are talking about the same thing. And so kind of the easiest way to start solving is to just look at the graph and look for where it crosses your x-axis. So a couple of things can happen. So if we jump down here now, firstly, we could have a graph that looks like these ones here. And if I'm looking for where it crosses the x-axis, because I'm trying to solve for x, like where is it touching the x-axis, it ain't touching at all. So if we have no roots or zeros, then that means there are 0 times that the parabola crosses the x-axis. So in this case, I would say that there is no solution. So no solution because there's no touchies. Like when I look at the x-axis compared to the parabola, they do not touch each other at all. And same thing over here. This parabola will never touch the x-axis. On the first one because it's above the x-axis and it's going to continue going up. And the second one because it's below the x-axis and it's going to continue going down forever. So no solution on those. Now what could also happen is that you have one solution. So I have one root or zero or one solution if there's only one time that the parabola crosses the x-axis. And so really what that looks like is your parabola is just sort of bopping off on that x-axis. So basically the vertex of my parabola is on the x-axis. Okay, so in this case, when I'm trying to solve for x, I'm going to look for just the x value that the parabola is touching, and here it's touching at -2, right here, and here it's touching at +2. And so in this case, we only have one solution because it's only touching one time. And then last but not least here, what could also happen is that I have a parabola that touches 2 times. So we have 2 roots or zeros when there are 2 times that the parabola crosses our x-axis. So I can see that this parabola is touching here and here. And so my roots, zeros, solutions, x-intercepts are at -1 and also 2. And it doesn't really matter the order that you write them in. I usually go smallest and then biggest, but it doesn't matter. They're both answers. So down here, if I'm looking at these parabolas, this first one is touching at this spot and then at that spot. So we have 2 answers, one at -1 and the other at -3. And I already broke my own rule. I went in the other order, but that's fine. And then over here, oh, I do have 2 solutions, but they're not very nice. And so for right now, we're going to say that x is approximately, so we do like a wavy equal sign, some values. And this is why graphing, or like to solve by graphing, is not always the best way to do it. For all the graphs we looked at so far, they cross at really nice spots, so that's easy. But a graph isn't always going to cross at a really nice spot. And so here I have to sort of guess what my answer is. Like this one is definitely in the negatives, but it's not quite to -1, and it's actually really close to 0. So maybe I guess that's like at -0.2 or something. Or maybe it's even closer than that. I don't really know. I have to guess, and I hate guessing in math. So we are going to talk about other ways that we can solve these so we know exactly where they are, just not yet. And then this one over here is at 1, 2, but not 3. Maybe it is right in between 2 and 3, so like 2.5. But again, it's kind of a guess. It's such a crapshoot. And I don't like doing that. I want to know exactly where it is. So we'll get to that stuff eventually. Now, these were all kind of nice because they're already graphed for you. So as just a fun little reminder over here, if I'm going to solve quadratics to find their roots or zeros or to find their x-intercepts, one way we can do it is to graph, my goodness, stop being blurry. There we go. Graph the quadratic and then look for the x-intercepts. Now our special cases here is if it doesn't cross, then there are no roots. If it crosses only once, there's 1 root. If it crosses twice, there are 2 roots. If the graph crosses in between, then we have to write in between values, which is when we're guessing, which we don't love. Okay, so we're going to try 2 in here where we have to fully graph. So let's say we take this first one as the equation y equals x squared minus 2x minus 8. Sorry, this got a little bit cut off. These are our a, b, and c values. So a in this case is 1, b is -2, c is -8. And I can tell right now, so this quadratic is in standard form, and I can tell right now that my slope is 1, which will mean that this is going to point up. And since it's going to point up, the vertex will be a minimum. Because I am in standard form to find my axis of symmetry, which is super important because I need the vertex, we do this little mini equation, -b over 2a. So if I do -b, I get 2, because a double negative will make it positive, over 2 times a, which is 1, which is 2, and 2 over 2 is just 1. So when I go over to my graph, I can actually get this going a little bit right now. Let's draw in our x and y axis. Oh no, it's ripping through the paper a little bit. I'm going to put it right in the center here. So I can draw in my axis of symmetry at x equals 1, so that vertical line through 1. And then I know somewhere along that line I'm going to have the vertex. So already I know that the vertex is at 1 comma something. To figure out what that something is, I have to take the 1 and put it in for x in my equation. So we'll have y equals 1 squared minus 2 times 1 minus 8. And so 1 squared is 1. When I multiply here, we get negative 2 minus 8. And so then when I simplify it, 1 minus 2 is negative 1 minus 8 is negative 9. Oh, crapola. I don't know that I can fit this on here. 1, 2, 3, 4, 5, 6. Let's count by 2s maybe. Oh, but then the other direction I didn't count by 2s. It's fine. We'll count by 2s. So over 1 and then down 2, 4, 6, 8, 9. Okay, so now we know that our vertex is at 1 comma negative 9. So I could write my equation in vertex form because I know that the a value is 1. I'd have parenthesis x minus 1 squared minus 9. We could make a table of values, but I'm super not into it. So from here, I'm going to just do that slope of up 1 over 1 on both sides, which then helps me to see that my y-intercept is negative 8, which I kind of already knew because standard form shows me that y-intercept of negative 8. And then as I kind of sketch this graph out, I can definitely see that I'm going to cross the x-axis 2 times. But the thing is, I can't really tell where, especially because I didn't plot a lot of points here. So my roots are going to be sort of approximate, or my x-intercepts are going to be sort of approximate. To me, this looks like we're counting by 1s on the x. So 1, 2, 3 and a half, maybe 4, because I sketched it out. Like, I don't know how good of a job I'm sketching. So we'll go with approximately 3.5, sure. And then the other one over here is in the negatives, and we'll say that it's negative 1.5 because it's between negative 1 and 2. But again, it's all sort of a guess because of how poorly I graphed E, which again is just another reason that this is not super reliable. Alrighty, let's try one more, see if we can get a better answer here. Let's say we have the quadratic function y equals x squared minus 6x plus 9. So my a value is 1, b value is negative 6, c value is 9. Because the slope is positive, this is pointing up, which means I have a minimum. We can find the axis of symmetry by doing negative b over 2a. So negative b will be 6. 2 times a will be 2. And so my axis of symmetry is 3. So as far as my vertex goes, I now know that the x value is 3 because the vertex is on the axis of symmetry. So to find that y value, we're going to plug it in to our equation. So y equals 3 squared minus 6 times 3 plus 9. So 3 squared is 9 minus 18 plus 9. Oh, dang. This is going to be negative 9 plus 9, that's 0. So the vertex is at 3, 0. So when I write this in vertex form, because the slope is 1, I don't really need to put the 1 out front. We'll have x minus 3 squared plus 0. Not so into the table of values, we're going to skip that. And so when we come over here to graph this, Okay, my x and y axis. I'm going to plot my axis of symmetry at x equals 3. And then my vertex is on that line at 3, 0, so right here. And then my slope is 1, so I can go up 1 over 1 on both sides. Also, my y-intercept is 9, but that's like way up here. It's not going to fit. But also, I kind of don't need it. I can totally see that this parabola is touching the x-axis only one time. And so I only have one solution right where x is 3. So this is an example of graphing working to find my solution because it like hit it at a really nice spot. But like we saw in this last one and the other one from the previous page, graphing is not always reliable because it sometimes goes through yucky points that I can't know exactly. So in the next couple of lessons, we're going to have to figure out other ways to solve so that I can find out exactly what my answer is. We'll see you on the next one.